So when I was walking around earlier today, helping you guys out, a lot of you guys were asking me about this question number 18. What's the force of the wall acting on the ball, causing it to boing, bounce off the wall? Okay. So force, that could be mass times change in velocity over change in time. Well, here's the mass, here's the time interval against the wall, so a tiny fraction of a second, right? But what about the change in velocity? And a lot of you guys were looking at this. Okay, so speed, something about 10 meters per second, but be careful, you cannot use the full 10 meters per second. You have to consider that this is a two-dimensional question and momentum is a vector. So you consider what's going along on the y-axis versus the x-axis. The wall is aligned with the y-axis. You guys see that? Okay. And interestingly, along the y-axis, the motion of the ball never changes. Right? If you just watch what the ball is doing along the y-axis, you would never even know when it collided. But along the x-axis, the ball completely reverses direction, kind of like you throw the ball straight at the wall and the boing bounces straight back. Okay, so that's what you care about. So the velocity of the ball headed straight towards the wall is this 10 meters per second multiplied by sine of 60 degrees. That's like 8.66 meters per second. And then when boing bounces the other way, that's like 8.66 minus negative 8.66, which is like 17.32 meters per second. So the change in velocity is 17.32 meters per second. So put it all together. Force then would be mass, 3 kilograms, times change in velocity, which is 10 sine 60 times 2, so that's 17.32 meters per second, then divided by this time interval of 0.2 seconds right here. All right, so on the solutions, here's the full thing. Solution number 18. So in the along the y-axis, there's no change at all. So throw that out. Along the x-axis, there's your impulse along the x-axis. Mass times change of velocity, v sine theta minus negative v sine theta, because this v stayed the same, it was an elastic collision, right? Work down, and you should get that many newtons right there.